Hello everyone, so my name is Pawan and here in this video we are going to discuss what is the dual. Yeah, I know, everyone know that what do you mean by dual. Like if the objective function is suppose maximize C transpose X subject to the constraint X less equal B where X is greater equal 0, then you all know that the dual of this primal is simply minimize B transpose Y subject to A transpose Y greater equal C where Y is greater equal 0. Yeah. You know all these terms, right? But in this video, we are going to answer the question why. Why? Why only this type of primal converts into this type of dual? Why there is no less equal sign here, right? Why is the constants variables are y greater equal 0? What is actual meaning of the dual? Why we do the things like in this way only? So let's get started. Consider a simple linear programming problem. Consider an LPP. Maximize 4x1 suppose plus 5x2 subject to the constraints x1 plus x2 less equal 1, 2x1 plus 3x2 less equal 3, x1, x2 greater equal 0. Okay, this is a simple maximize linear programming problem. We have to find its dual. Okay. So, suppose I multiply this equation with y1, this equation with y2 and add both of them. Being positive, y1 and y2 being non-negative, the inequalities won't change. So, the resultant I get is y1 x1 plus y1 x2 is less equal y1, 2y2 x1 plus 3y2 x2 is less equal 3y2. And if I add these two, I get y1 plus 2y2 x1 plus y1 plus 3y2 x2 is less equal y1 plus 3y2, right? So now what? See, this thing somehow looks like objective function, right? Just we have y1 plus 2y2 in place of 4 and y1 plus 3y2 in place of 5. Now observe this that x1 and x2 are non-negative, right? So if this value will be greater than 4, greater equal, and this value is greater equal 5, then 4x1 plus 5x2 will be in particular less equal this, and which is in turn less equal this. So what we observe here is whenever y1 plus 2y2 will be greater equal 4 and y1 plus 3y2 will be greater equal 5, this value which is y1 plus 3y2 will be what? An upper bound, right? Will be an upper bound for our objective function, which is 4x1 plus 5x2, right? And we have to find the supremum of this function, 4x1 plus 5x2. We have to find the supremum of this function as long as x1 and x2 are in this domain, right? And as we know by the definition of the supremum, it is the least upper bound, right? So in a sense, for finding the supremum or the maximum value of this function, we can alternatively find the minimum value of this function for y1 and y2 satisfying these points, right? Hence, the dual dual is formalized simply minimize this function with respect to these constraints where y1 and y2 are already taken positive. So this is simply the meaning of the dual. What we just instead of finding the supremum of the objective function, we just find the minimum value of its upper bounds. That's all. So if we generalize this thing now, we just observe this for 2 cross 2 thing. Suppose we are going to generalize this. Maximize objective function we write in this way, C transpose X, where C is a row vector C1, C2, not C, sorry, C transpose is a row vector C2 up to Cn. X is a column vector of unknowns x1, x2, xn, subject to the condition Ax less equal b, x greater equal 0. Right? A is a m cross n matrix of coefficients and b is an m cross 1 vector. Right? So this is the primal maximization problem, and as we did in the 2 cross 2 case, we just have to multiply each equation in this, suppose I will write this as a11 x1 plus a12 x2 go on till a1n xn less equal b1 goes all the way to am1 x1 am2 x2 plus amn xn less equal bn. Similar to the 2 cross 2 case, we multiply each by y1, y2 up to ym, right? And we add all those. So in particular, we will get a11 y1 plus a1, not a1 to a21, right? The coefficient of in the second equation, a21 y2 plus up to am1 ym times x1 plus same thing will go up to last variable, which is a1n y1 plus a2n y2 plus up to amn yn times xn will be less equal summation bi yi. I write it in short now. I goes from 1 to m. Simply sum of all these multiplies by y's. Okay. And as long as this term is less equal greater equal c1, second term will be greater equal c2, and nth term will be greater equal cn. Similar to the 2 cross 2 case, we get the resultant this as an upper bound for our function. So we have to minimize the upper bounds, means we have to minimize summation bi yi. I goes from 1 to m, subject to the conditions a11 y1 plus a21 y2 plus up to am1 ym greater equal c1. Similarly goes until a1n y1 a2n y2 up to amn ym greater equal cn. Right? Okay. And subject. Okay. Also these yi's are all greater equal 0. So we just if you reformulate this into matrix form, what this is looks like is b transpose y, right? Like it is b1 b2 up to bm into y1 y2 up to ym dot product, simply matrix multiplication. And what this look like is, if you put it in matrix form, it is a11 a21 up to am1 a1n a2n amn y1 y2 ym is equal to is greater equal to c1 c2 up to cn. So this is simply the transpose. Yeah, if you look what was a was simply this matrix, right? a11 a12 go to a1 n, then a21 a22 till a2n, and this is am1 am2 up to amn. So if you observe, this is simply its transpose, right? A transpose, right? A transpose y is greater equal C transpose, or just simply C. No, C is the column vector, right? C. So that's all. This is the interpretation of the dual in general.